Login accepted.
Well, hello everyone. Welcome back. This is the second day of Devoxx Poland, and I can barely see any one of you through these slides that are shining directly into my face. So I just want to see quite quickly who is here for the first time at Devoxx Poland. Wow, definitely like 20% of you. That's pretty good. Okay, so the topic of today that I have for you is going beyond ORMs. So let's do a quick poll. Who likes working with SQL directly? A few hands, okay? So for those of you that don't like working with SQL directly, do you enjoy working with ORMs? Not that many hands, of course. So, okay, so this might be the right talk for you. Okay. So my name is Almiray. I'm currently employed by Oracle. I work at the database group. Disclaimer, this session is going to showcase a feature that is available in the Oracle database. Now, I know that most of you have had to deal with a database at some point in your time, regardless of the kind of architecture that you use for writing applications, whether it's a monolith, whether it's microservices, whether it's something else. And it is very likely that either you have already dealt with the Oracle database, or you will eventually do it. Why? Because it's one of the most used databases out there. It's not the only one, of course. So what I would like to do today is showcase a feature that has been added to the most recent version of the database. And this feature should allow us as developers to have a way, perhaps a little bit around not having to use ORMs. So I'm not going to say this feature is going to kill ORMs. I think that using SQL and using ORMs or using any other native way to talk to a database will continue to be with us. It's just that this feature will allow you to do other stuff without you having to write a lot of, let's say, plumbing code in order to get things done. That's the whole point where we want to do things. So I'm going to start with what is the current state of when writing relational data or relational applications. And then we turn into documents because, well, we know that there is SQL has been with us for a long, long time. Relational data has been with us for, what, a little bit more than 40 years. And about 16, 17 years ago, we got the NoSQL revolution. So everybody was like, oh, I don't like relational. I don't like SQL. Let's go with documents and columns and key values and whatever. And a few years later, those things said, we need some way to query our stuff. So let's write something that looks like SQL, but it's not SQL. And everybody ended up writing something very much like SQL anyway. So, yes, this is an Oracle database talk. And one of the things that I like about the database, and not just because it pays my bills, is this little thing that we like to call the conversion database. Oracle is not the only one that has this. This is known by other vendors provided as the multi-model approach, which means you can have more than one format under the same database engine. So you can start with relational, and you can have JSON documents, and graph, and spatial, and what have you, all these things. The advantage of hosting all these different formats inside the same database software is that very likely that same database software will allow you, will give you ways to query all of them in a simplified manner. Because what happens today when we need to use different formats, and very likely what we do is just grab what is the most performant or the most well-known vendor in this space, and then this other space, and this other space, and we put everything together, and we go to the trainings, and we get to use their APIs and the documentation, blah, blah, we know this by heart. And at the application level, which is the level that most of us will have to deal with, now we have to figure out a way to query data from this place, and query data from this other place, and query data from this other place, and then put everything together. So grabbing data probably is not that problematic. But when you need to write data back down into those all different formats and make sure that everything makes sense, that if there needs to be duplication, is as minimum duplication as possible, and multiple transactions and whatnot, you start to see that things start to get complicated when we have to deal with separate database or data source vendors. Doable? Yes. A pain in the neck? Very likely. So that's why many vendors now provide you different options to host multiple formats inside the same engine. Oracle happens to be one of them, and I believe is the one that provides you the most formats in such a way that it also allows you to query across all the different formats using just one language. And yes, that language will be SQL and has extensions so that you can use graph, and you can use projections on JSON documents as just across all the properties of your JSON documents, regardless of the nesting, as if they were just columnar data. That's one of the advantages. So let's say that you have your typical model. When we're dealing with relational data, what we want to do is take something from the real world, abstract it into entities, and then make connections to all of them. Right? So let's say that we have something like a conference application where we have an attendee and a session and a speaker domain entities. And for each one of these, we will have some sort of relationships among each other. And for each one of these entities, we also will have to express properties about them. And these properties will eventually map into a series of columns. We will have all kinds of scalar types. You will have the string, you have the booleans and the integers and what have you. And there you go. At some point, eventually, because we have these relationships across the different entities, we will have to find these things, and we have to ensure that we have the connections across the different entities. So that's why we have the concepts of primary keys and composite keys and foreign keys and all those things. Right. So when we're dealing back into relational, we have to think about all these different things. And most importantly, some people will tell you, when you design this relational model, we have to ensure that the definitions are normalized in order to reduce duplication, which is good, right? Okay. So the advantage of SQL is that there's a lot of documentation. There is a lot of research. There is a lot of things that have happened since relational came to be. It's, most of the problems are well understood. We have many ways to deal with these things. And we have things as the optimizer. We have the query planner. We have many things built around it to ensure that the queries that we write will probably, or most likely, will be rewritten by some other automated system within the database so that they get much better as time passes by, so that we get better performance. So it will be, there might be suggestions to add indexes someplace. There are many things that can happen. This is great. But the problem that we have with relational is that we had to invest a lot of effort up front in order to reap these benefits much later as we continue in our development process. So we have to think a lot in how we want to realize, we have to materialize this abstract model, these entities, into our relational model. And if we get it wrong, yeah, that's a bit of a problem if we're already in production. And we now have, well, by now I mean like 10 years ago or so, we start to have these additional tools that allow us to do migrations as the application was putting up or as we go. So we have tools like Liquibase and Flyway. These are the free ones and commercial ones. Oracle obviously also has its own migration tool. So we can do this while we are starting, while we're offline, or while we're running. So it's up to you. But the whole point was to ensure a way that if we made a mistake, then we can move on into a better way of the model. Or if we need to accommodate a new use case, so we need a new set of tables, and add new properties, new columns to the table, we can do so in a way that we don't disrupt operations. But then again, it's a lot of things that now we have to take care of. Okay. So if we had an application like this, where we had our model, and in the end, what we want to do is perhaps display a schedule for a given attendee. So as yourself, you want to see everything that you like about the particular conference. So you want to see in which room, what session, what speaker or speakers, and at what time, all this. So given how we have set up the event, there's going to be duplication in the sense that a room can have multiple sessions. A session can have at least one speaker, it could be more. One speaker can deliver one or more sessions. So as we start to see the schedule grow, we will see the run number appear multiple times, and the session might be just one. The speaker may appear multiple times, and of course, depending on how many days you are in the conference, there will be multiple time slots at the same time, like right now at 4 p.m. Okay. So we can put all these things in the database. We know this. So we've been doing this for years. Okay. But since, 15 years ago or so that we got this NoSQL revolution, we also got this format called JSON or document databases. And there are many ways that we can represent a schedule as the one that I just described in using a JSON format. So one way could probably be this. We take the attendee as the root object of our document, and we add some properties pertaining to that attendee, like the name, the company, I don't know, maybe if I don't know what anything else you would like to have for the attendee, GDPR and all that thing. But then for every attendee, we have the number of sessions that that person is interested in, and for each one of the sessions, we may have at least one speaker. And the other way that we can have this is this way. So at the root of the document, we may have an array or a list of sessions. And for each session, we want to see the speaker and the attendee. And notice that the attendee and the speaker are nested at the same level from the point of view of the session, instead of having 2 or 3 levels deep. So it's up to you to define how it looks like in the use case. Or we may have something like this. The root of the document is the speaker, and the nested objects are the session or sessions that the speaker is related to. The speaker is going to deliver more than one session, then we'll see more of these things. Again, we could have it as an array of speakers with multiple sessions, or just one speaker with multiple sessions as well. So we have this flexibility that regardless of what data we have, we can represent it in many different ways. If we look at it in the relational way, everything is kind of like set on stone. We have a schema. We will know exactly how we want things to be connected. But in the document world, we can move things around. We can represent the same data in many different ways, depending on the use case that we need. It gives us a lot of flexibility, right? So this is good. The problem that comes later is that there's a lot of duplication in these documents because, well, if we want JSON to be really readable by us humans, we need to understand everything that's going around. So what if we want to do this thing around? We start with a simple document like the one on the left, that it has a little bit of duplication over there, and we start to normalize those documents. And by normalizing, we start to get fragments out of that document to reduce that duplication. And that's when we start to see that we introduce some sort of identifiers. And more, and more, and more. And if you have big documents, then there's going to be a lot of fragments. Yeah, those fragments, the data that they contain will be definitely unique. And we have all the relationships together. But we started with something very simple on that side, which is easy to understand for us humans and the machines as well. And then we turn this into something that is fully normalized, that it makes a lot of sense for machines to do the relationships very quickly. But for us, it's like, it's a bit of a problem when we start to get a lot of data. So when we normalize documentations, we lose completely the simplicity that we originally wanted for having, say, documents in the first case. So it's like having the worst of both worlds. So let's not go there. Because in the end, these normalized documents starts to look a lot like exactly the shape as a relational table if we started with relational data. So what was the point of using documents in the first place? I don't see it. Okay. So the good things about the documents is that we can start with them very, very quickly. We can move and we can pivot. If the data that we need to send to the client, to the mobile or to the browser doesn't fit exactly the same shape, we can move things around very easily. And if our application is small, this is not a problem. And because most of the clients, browsers and mobiles nowadays consume JSON, is anybody sending YAML across the wire to the clients? I hope not. But you might recall in the old days, we used to send XML before JSON became all the rage. So it's perhaps pretty much the same idea. We just send declarative data across the wire. But nowadays, JSON is kind of like the native way for everybody to connect with. So it makes sense to start with this thing. The problem happens that as our documents continue to grow, then complexity creeps into our application, and things start to break down a little bit. In the other case, in relational, starting is a bit slow because we have to think about, again, how we make this, how we put those abstractions, those entities into our relational model. And as our application grows on complexity, then we start to reap all the benefits. If you have to do reporting, have you ever tried to do reporting on document-based databases? It's not that easy, and it's not a lot of fun, but it's that simple when you do that in relational data, right? So the question will be here. We can get the benefits at the beginning if we use documents, and we can get benefits later on if we use relational. But if we start with one document, if we start with one format, and we want to get the benefits later, at some point we will have to do a format migration. And depending on how we write our applications, that kind of like feels as rewriting the whole thing. And we definitely don't want to do that. So is there a way where we can start quickly, simple, with documents, and then as time passes by, move gradually into relational data to always be at the highest possible level of efficiency or performance? Well, this is exactly what we want to propose with this feature that is called the JSON Relational Duality View. So it's not either or, it's actually doing a plus. We're doing both at the same time. And by the same time, I don't mean we have a copy of a document, we have the data in a document, and we have the data on relational tables, so there is duplication. And whenever you want a document, you query from one side, or you want a relational, you query from the other. No. What this feature says, we're going to store the data in one format, one way, one copy only, and then you can query in document way, or you can query in relational way. So this is basically it. You get all the benefits of both formats at the same time. That's what we call JSON document relational duality. Okay, so at the beginning, we had to choose a given format for storage. This format for storage will be relational, right? So you will continue to create schemas, but one of the advantages is, as an Oracle is not the only one that does it, it allows you to store JSON in a column. So you can have relational data, and one of those columns, or at least one column, could be JSON format, and you can store a document completely on that one. And you can do queries across all those things very easily, not a problem. And then what we want to do is expose this table or set of tables, because it could be more than one, as a JSON document. So once again, the table, the data remains relational, so we can do SQL queries through it, and we can put every other tool that we know that has to deal with relational data through it, not a problem. But the view to the outside world will be a document. And when I say view, I don't mean this as a materialized view. This is a different kind of object. It's a live object. Everything that we do on SQL will reflect changes when you query for that document. But then the other thing is, I think you may be thinking, it's relatively simple to expose relational data as a JSON document. That seems like a trivial transformation. What happens if I have a document as an input, and I want to insert new data or update existing data just by having that document as an input? Someone has to map that document and deconstruct it into a series of SQL statements or some other way that we can update or insert the relational data, right? Who is going to do it? Are you going to do it? I hope not, because that is not fun. The database should be the one to do it. And once again, this feature is the one that does it. So there are two ways that we can define this mapping. We can use JSON or we can use GraphQL. I'm showing the GraphQL version because it's concise, it's shorted. So on the one side, we have a definition of what is known as duality view. And this thing will map, in this case, is mapping attendee and attendee session and speaker, so 4 tables. And given this mapping, we can generate documents that look like this one. Now, this document will be for reading, but also will be used for writing of inserts and updates. And you can also delete if you want to. OK. The thing is that you see there are some annotations here on nest. But when we start to look down more into the definition of this feature itself, we see the names of these objects in the graph definition map to the names of the tables. So attendee, session, speaker, and the mapping table within these two entities, attendee and session, which we would like to call attendee_session. So that's the first thing. The next are the properties that we expose for each one of these entities. So we have _ID as the root, and we got name, and we got company. Given that these two columns have the same name as the properties, there is one extra shortcut that we have used, which is only use name and only use company without having column name and column company, because they are pretty much the same. Notice that in the case of ID, the name of the exposed graph element is different from the relational column. And we continue to do the same thing with the other elements. There's also annotations where we can tell the database what we want to do with relationships. In this case, whenever someone puts a document for insertion or update, anything that is in between this relationship, the attendee sessions, will allow us to delete that relationship. It does not delete the session. It just deletes the relationship itself. Or it can insert a new element in that relationship, or it can update the existing relationship. It will not necessarily update the session itself. And we can also tell the view to unnest. That means takes the properties of a deeply nested object and then put them into the parent or the root, so that if you don't want deeply nested objects, then you can just move it one level up. Perfect. So in the end, we can turn relational data in a document that looks like this. We can query it using SQL, or we can query it using document functions. It's up to you. You have choices. So what we are proposing is that if you are writing REST-based applications, and it's very likely that you will be dealing with JSON as the document format for input and output, then you don't have to write all the glue code or the plumbing to take some JSON document into Java objects, do some massaging on the data, and then turn that into entities or SQL statements, use the ORM to send it to the database. And the same way back. We don't have to use the ORM to grab that into Java objects, which will eventually be turned into JSON documents that the client can understand. So if we can use the JSON document as is, as the lingua franca within client and server, this will be much simpler. And given that this is the way that it's understood, you don't have to write that glue code. Someone else will do it. It will be either the library, it will be a framework, or in this case, will be the database. Now, the advantage of doing it this way is that when we're sending data for writing, and we're touching multiple tables, and there's a lot of concurrency, there's a lot of requests coming in, and everybody wants to talk to the same databases, eventually, we are going to get some contention of these resources. Who is going to write first? Who's going to win? Are we doing the duplicate writes and all those things? Well, so the database knows. Because we're doing these mappings, this JSON duality view, it knows exactly what kind of constraints to which tables you're touching. And if something does not match accordingly to what the database knows, then, of course, there's going to be an error. So we have locking mechanisms in place to ensure that we are not overwriting data when we shouldn't. OK. So the advantages of this is that we can write less application code. We can trust the database to do the right thing. And because JSON duality views are baked into the database, they are not dependent on a very specific programming language. So if you're using, who's using Spring Data today? I assume most of you. Is anyone using Quarkus? Just a few hands. Yeah. Anyone here using Micronaut? Not yet. Highly done. Or Jakarta Data, Jakarta API, something like that. Exactly. So we have plenty of options. So just in Java, and just switching from one library to another, some people will find it a little bit hard. We can try Open Rewrite to do refactorings to translate from one another, but it doesn't work all the time. So we still have to do some manual work, and we don't want to do that. It's not often that we switch from one framework to another in the same project, but it will happen at some point. Now, think about going away from Java and then using another language, and then another language, and another framework, and all those things. This also can happen. So we had to retrain ourselves. We had to relearn a few things just because we need to map these documents and relational data. But because the database is the one in charge of doing these transformations and these mappings, they are completely programming language independent. So that's another benefit. OK, so this is what I want to showcase. But in order to run this, we need a database. I don't know if you knew, but there is a version of the Oracle database, a full version of the database called the Oracle Database Free. Latest edition is called 23 AI, which was released, the first version of this database was released in April last year, and the official release came out in May of this year. The company did something completely radical and new. Never before have we ever released a product like this for developers to have access first. This was released as a developer early access so that all of us can have a go and play at this and discover what are the new features. And May of this year is where everybody else had access to the latest version of the database. There is this particular version. You can download it and use it on Windows, on Linux. You can put it on containers as well. There is a cloud version of the database that contains all the different features and a few other things. You can obviously get a license for the database, or you can get a version for free. Just sign up for the Oracle Cloud. There's a free version out there. It gives you access to 2 instances, fully fledged instances of the Oracle database, where you can use this feature and a few other things. All right. You can also download, as I mentioned, containers. So there's a container registry for the autonomous version and for the free version as well. And these are the official images. There's a QR code over there for navigating to the URL. And if you want to find about all the stuff that is also put out there for free, most of the things that you see here are for free. Some others will require a license for you to download it. All right? But there are another set of images that you can use with Docker or Podman or any other container runtime. And this is the one that I would recommend you to use. Because this one, the download size is about 900 megabytes, so it's less than 1 gig. And the startup of the database is about 10 seconds. Just picture that. If you had dealt with Oracle before, you know it's a bit tricky to get set up, and it takes a while to get started and all the same, blah, blah, blah. 10 seconds, or even less, for a fully fledged Oracle database. This is for version 23 AI going forward. And if you need an older version of the database, then there is another set of images that are also slim and fast. OK, so why I mentioned this? Because test containers. At some point, we need to test our applications. Who knows about test containers? OK, like half of the room. So 2 things that I will expect you to take away from this session. One is that you have access to the Oracle database for free. You can put it in development, testing, and production. And second, use test containers for testing. It will change your life. So if you are testing applications for any kind of software, any kind of real dependencies, we know it's a little bit of a problem to test. So this was me years ago when I needed to test an application with a database. I hope that wasn't the case for you. I needed a specific version of a given database software. I was testing with Oracle XE many, many years ago. And I didn't have access to that right instance. So I had to call the IT person and say, hey, can you set up this and this and this particular version of the software? And that 3 months later, he will get it done. It was already too late. And he set up the wrong version because I already needed a latest edition. So, OK. If I got that instance running, now I had to keep it as my precious. Nobody will have access to it because if they touch it, if they change the database state, it might break my test cases. Because I need to set up a state exactly at the right time, at the right moment, and I do the right assertions, otherwise things will be break. And once we got CI servers and CI/CD, we now have the same problem, which is I cannot share this single instance with me with different, when I'm running with different processes, so I cannot run in parallel. I cannot share with my teammates. I cannot share with my CI servers because timings. It will be much, much better if I were able to set up that database or that real dependency in such a way that I can boot up my test cases, and there's a new pristine environment that contains the real dependency, and then I just touch it. Who has used H2 or HSQLDB to fake out a real database in testing? A few hands, exactly. So the alternative, instead of having an instance like that I just described, I use an in-memory database. Cool. But the moment that an application requires access to a specific property of the real database, can I test this with the in-memory database? Very unlikely. So test containers give me access to the real thing as long as I can put it on a container. So the images that I showed you before, all of them can be run within test containers. And test containers had a set of modules, which is just a fancy way of saying pre-configured ways for running a container for a given software. In such case, we have one for the Oracle Free Edition. So this is as minimum as you have to go. Once you have configured the given dependencies for running test containers with JUnit 5, just instantiate a container with the given image. You might want to set export different ports or define a username or a password if you want additional configuration, and then just go. Start it. It's as easy as that. And test containers will take care of starting the container, making sure that it's alive and it's ready once you start running your test cases. And when this is done, it will kill the containers and clean up all the resources so there is no leakage. So once again, if you are not using test containers already, please do so. It will do yourself a favor. It's really, really that powerful. So with this now, I can show you a demo. I'm running the database on Docker because we don't have a version for Mac. And I do have an application here. I'm showcasing Micronaut. I know that most of you said that they're using Spring. And the great thing that I like about all these different frameworks is that even though the names of the annotations and the names of the base classes sometimes may be similar, sometimes they are not, they provide almost the same behavior. So the knowledge that you get from using Spring is translatable to using Quarkus or Micronaut or the others, and vice versa. So I have here something called a set of entities. I have a student, I have a teacher, I have a class. These are domain entities. This is Micronaut data, which is very similar to Spring data. Some of you that have seen how this software has changed across years, you might remember a framework called Grails that gave us something called GORM, the Grails Object Relational Mapper. This is the beginning of what you guys now know as Spring data. GORM did it first, and it was groovy. So we have these dependencies, we have these entities, such as the student that has an identifier, has some basic properties, has the relationship with the class or course, and here we have the class itself. Again, using a different set of entities and annotations. We just have to understand what is the real name of the annotation for the target framework or library that we want to choose. And once we know what kind of behavior it provides, we can map it to something else. So if you are used to Spring data, this should look very similar to you. So we have entities. And we have repositories, just like in Spring data. In this case, a repository is just an interface that tells me what kind of operations I can invoke on a given entity. In this case, it will be on the teacher entity. And it gives me access to the basic CRUD operations. So I have create, read, delete, update, and I have a lot of dynamic finders based on the names of the properties of the given entity. So the teacher, I can find it by that ID. I can find it by a name. What else does a teacher have? What other properties they have? I only have ID and name. But for a student, I can find it by an ID, by a name, by an average grade, and I can navigate the relationship that it has with the classes as well. So these repository objects give me a lot of behavior. I have one here for the student where I decided to add my own custom finder for name, which is kind of like overwriting the one that it already provides. But I'm also adding a few other set of methods that will eventually touch the JSON Duality View that we will see in just a moment. So what these methods are trying to do is partial updates over JSON documents, if you want to go that way. I'm just saying it's a possibility. It's not something that I would recommend all the time, because that's what we have the ORM for. Because it gives us exactly those very simple ways to update just one single property within a given entity. But I do have stuff like, say, for example, if I want to find an object, or a student in this case, by a name, I can issue a SQL query that looks like this, and it touches something called data. What is that data object? We'll show you that in a moment. But notice that the result is a string. Why is that? In the previous finder, we got a full object, a Java class, a domain entity that we defined. But in this case, we're getting a string. This is because what we're getting from the database is the document itself. We are not doing a transformation of relational into Java objects, into JSON, so they can send it to the client. We just get the JSON directly from the database, and we ship it directly to the client. That's what we want. So what are we missing here? We're missing the schema definition. So you can let Hibernate or the ORM to generate the tables for you. In this case, I decided to do it explicitly, so we know that we're starting with relational data. And here, I have the JSON Duality View definition. As I said, we can use JSON format, which looks a bit bigger than the GraphQL format. So in this way, we can insert, we can update, we can delete, and we can query a new student or a series of students with the relationship that it has with the classes. Okay, so let me show the data which is already running here. So let's do a select from student. There we go. So this is the information that we currently have for the student. I just gave a demo on Vilnius. That's why we had that name over there. But I can, as I mentioned something about the data. There is this student DB. That's the name of the duality view. Let's use that. Select start from student DB. And that gives us JSON document. And if you see, the name of the column is data. So that was the data that was using on the SQL statement before. So when we go back to that finder, now it makes sense. I'm selecting the document from the given duality view where a property, in this case, the student, which is at the root of my object, matches whatever input I'm sending it. That's what I'm doing. And if I find a match, then I will get a document out of that. So the final thing will be the application itself. In this case, we have a REST controller that it's mapped to the student's path. And let's say we want to find one document by an ID. So we issue the findID method. And notice that we're asking the student repository to find an object based on the duality view. If we were to do this with the ORM, we would have to create a student object and do, well, we actually will get a student object from asking the repository. And the student object will eventually get mapped into JSON so that it gets sent to the client. But because the database now is giving us the document directly, we just send it as is to the client. If we find all of them, in this case, we're listing all the students, we're also asking the repository, give me all the documents. This select statement that I did right here is pretty much what we want to see invoked somehow here. We get a list of documents, and then send it to the client. There are ways for we can update the different values, but I want to showcase one particular thing, which is this. When we want to create an object, we want to create a new student using just regular ORM. We get some input from the client. So we get some JSON, like the name of the student, the classes, all those things. We map that into Java objects because we have to ensure that we have data that fits the use case. That means it is in the right shape. It has the right type, so something has to be an integer, and the name of the property has to be name, and the name of this other property has to be company, and whatnot, exactly. So that's what the DTO is doing for us, and the library is doing a lot of magic for us. This is okay. Then we create an entity of that student with the data that's coming from the client. We ask the repository to store that. If it works, all the IDs get populated, and then we return the student back. The return type of that method is an object that gets eventually mapped to JSON. Boom. The alternative of using JSON Duality View is that we expect a document that we can store directly into the database. And if that is the case, we ask the repository to just grab that document and do it. Send it to the duality view. If what we're receiving is just text, is gibberish, it's not JSON, the database will complain immediately and we get an error. This is what we want. So the first thing that the database is going to do is check if it's syntactically valid JSON. The next thing it's going to do is it semantically valid? Are you sending me a student object that matches the expectation of that given student view? If that is the case, I will do an insert. If that is not the case, if something is missing, or you send me a class or a teacher when we're expecting a student, then of course the database is going to complain. If there's any violations of the constraints that we have defined on the tables, of course there's going to be a problem. And there is one thing in this particular version that I'm running of Micronaut that I cannot get access to the ID that was just inserted. So technically speaking, these two methods that I see here for creations are not identical, because on the first one using the ORM, I can get the actual object that was inserted with all the IDs, all the new things. But on the second one, I will have to issue a second query to find out what was inserted so that I can get the IDs. So I'm just saying that in the future, obviously, this will work. And again, this is one particular thing because I'm using this specific version of Micronaut data, which is not the latest one. So let's run this application. That is connected to this database that I'm running on Docker. So here we go. And we can issue some queries, such as I have here in a README, where is the different queries that we can run. For example, if we want to query all the students that we have here, we get that. That doesn't look very nice. We can pipe this to JQ. And we get a list of documents. We can, I think that there should be a student with ID number 1. Let's see if that is the case. Here we go, and we just pipe it to JQ. And we get just one single student. Perfect. We can do stuff like this. Let's grab this query, which will send a document to the database. Let's change this so that instead of saying Peter, we say Poland. Let's change it even better. Let's make it Krakow. And the average grade will be 10. You're excellent. So here we go. We grab this. We put it on the terminal. And boom, there we go. So when I query the data, remember I send a document, and I issue this statement. Now we got relational data. And I can get it back again. What ID we have? We got 85. So when I query students with ID 85, I get the document. And I can set, if I have the other endpoints enabled, I can send endpoints for updating any given properties. So this will be the advantage. So again, when we look at the kind of code that we can write, we can do both. I'm not saying let's get rid of ORMs completely. They're still useful. But notice that as your complexity grows in your application, you may need to do more things in your regular ORM. In this case, in the student, we have to ensure that we have the right set of classes or courses objects. That's why we're doing these kind of things here. We manually had to do this, because otherwise it wouldn't work. Whereas in this case, we're expecting the document to have everything. And if that was not the case, we still can do things either at the application level, or we can let the database know that, which is exactly what we're doing here. We're transforming the document as is in the database before we perform the update, or before we perform, in this case, the insert. So we're grabbing all the classes objects based on some transformation here, and then we generate the document in the right shape, which will be accepted by the duality view. This is basically what we're doing here. OK. We go back to the slides, and we're almost done. So with everything that you have seen today, and everything that you have seen in the other sessions, you may be excited to try out these things. And that's a good thing. When you go back home and go back to work with your teams, you will probably tell them, hey, I discovered these things in Devoxx Poland. I'm quite excited. would you like to try it because this and this and that? And very likely that your teammates and your manager will tell you, nope, because we're too busy. We need to deliver to production right away. We don't have time to deal with these things. Don't be discouraged. I will propose to you, build a proof of concept of the many different technologies and methodologies you have learned during the conference, and then do a showcase to your teammates. Do a brown bag session. Do some sort of presentation so that they can understand the benefits that you have learned also while you were here at Devoxx Poland. We have a set of free resources for you. It's not just the database that you saw earlier, but there are so many other things that we have available for free. Oracle has a lot of open source projects and also provides software for free for developers. So the first link will give you access to that. There's tutorials, there's documentations. There are also some certifications, if I'm not mistaken, but there's a lot of software as well. And if you happen to require more information about the database, well, the other resources will give you access to all these things. One more reminder, you can have access to the Oracle database for free in premises, or you can run it on a container, or if you want to, you can also run it on a cloud. And in case that you may be wondering, well, if I do this, I may be locking into just the Oracle Cloud OCI. Well, since I think that was last year that we announced a partnership with Microsoft, so you can run the autonomous database, the cloud version, on Azure. And just last week, Monday, we announced, so that was, when was it? June 10th, that we announced a partnership with Google, so you will be able to run the autonomous database also on top of the GCP. So there are now more ways, more cloud offerings for you to use the Oracle database. So with this, thank you very much for your time. So once again, let me remind you, you can have access to all these things, and make sure that your teammates understand the benefits of everything that you have learned at the conference. If you have any questions, I'll be very happy to have them. And for anyone that asks a question, or if you just want to come by, I have some Swiss chocolates with me. Thanks so much.